We might just be on the verge of cracking the code to limitless, clean energy. And the key isn't some far off fantasy. It's being built right now in one of the most ambitious science experiments in human history.
What if I told you that the key to solving, well, everything from our energy needs to climate change wasn't just about building more solar panels, but about building a miniature star right here on Earth? It sounds like something straight out of science fiction, right? But believe me, it is happening.
So get this. Down in the south of France, a massive team up of 35 different countries is underway. They are building a machine called ITER, and its entire purpose is to master nuclear fusion, the very same power that fuels our sun.
Okay, so let's get into it. To really understand what they're trying to do, we first have to get a handle on the science and see how it's totally different from the nuclear power we're all familiar with.
So, what makes this so new and exciting? Well, when you hear nuclear energy, you're probably thinking of fission. That's where we take heavy, unstable atoms like uranium and split them apart. It works, for sure, but it also creates that nasty, long-lasting radioactive waste and carries that small but terrifying risk of a meltdown. Fusion is the complete opposite. Instead of splitting big things, we're smashing tiny things, like hydrogen atoms, together.
And this is exactly why fusion is called the holy grail of energy. First off, the fuel is practically infinite. One of the main ingredients, deuterium, is just found in regular old water. Second, it's incredibly safe. You can't have a runaway meltdown with a fusion reaction. If anything goes wrong, it just stops. And the main byproduct? It's not toxic waste, it's harmless helium. You could fill balloons with it. And third, the amount of power you get is it's astronomical. To really wrap your head around that power, let's try a little thought experiment. Imagine you take the lithium out of one single standard laptop battery,
And you mix it with the deuterium that you could get from just half a bathtub of water.
that tiny bit of fuel from those super common materials could generate enough electricity to power a regular house for 80 years. 80! That is the incredible promise we are talking about here.
So you're probably thinking, if fusion is so great, why aren't we using it already? Well, that's the billion-dollar question, and it leads us to a truly monumental engineering challenge and the incredible machine they've designed to solve it. To make fusion work here on Earth, you literally have to recreate the conditions inside a star. And that means you need heat, an absolutely staggering amount of it. We're talking 150 million degrees Celsius. Yeah, that's 10 times hotter than the actual core of the sun. At these temperatures, they're just insane. Matter doesn't behave like a solid, a liquid, or a gas anymore. It becomes something else entirely: plasma. Think of it as a superheated, electrically charged soup where electrons have been ripped away from their atoms. Which, of course, brings up the biggest problem of all. What on earth can possibly hold a substance that is 10 times hotter than the sun? Anything it touches would just vaporize instantly. And the answer is, well, it's brilliant. You don't use a physical container at all. You use an invisible one. A magnetic cage woven from some of the most powerful magnetic fields humanity has ever created. This amazing machine is called a tokamak, and here's the basic idea of how it works. First, you puff a little bit of hydrogen gas into a big, donut-shaped vacuum chamber. Then you blast it with energy and heat it up into that plasma state. That's when these massive, superconducting magnets fire up, trapping the plasma so it floats in the middle, never touching the walls. And then they squeeze it with immense force until the atoms fuse and release all that energy. And here is where things get absolutely wild. This might be the most mind-bending fact about this whole project. While that plasma inside is burning at 115 million degrees, the giant magnets surrounding it have to be kept at minus 269 degrees Celsius. That is colder than deep space, just a few ticks above absolute zero. It is, literally, one of the hottest and one of the coldest places in the entire universe, separated by just a few feet. Okay, so here's a really crucial point. ITER itself isn't actually designed to power a city. Its one specific scientific mission is to prove that we can get way more energy out of a fusion reaction than we have to put in to get it started. The goal is a tenfold return. Put in 50 megawatts of power to heat the plasma and get 500 megawatts of power out. Pulling that off, well, it would be a complete game changer for humanity. And that brings us to where the project is right now and what the ultimate dream really is. So where are we today? Well, this incredible 23,000-ton puzzle is almost complete. The biggest components, like the world's most powerful magnet, this thing called the central solenoid, they're already in place. Right now, international teams are in the final stages of testing everything, all getting ready for the next huge milestone, achieving first plasma. That's the moment they turn the whole thing on for the very first time.
And why does it all matter so much? Because the dream of ITER and the commercial power plants that will hopefully follow it is a future with clean, safe, and, for all practical purposes, limitless energy. A future where having power isn't decided by who has oil or gas. You know, what might be just as amazing as the science is who is building this. In a world that feels more divided than ever, ITER is this incredible symbol of what we can do when we decide to work together. We're talking nations that are often rivals on the world stage, all partners in this, sharing their best minds to solve one of the biggest challenges we all face.
Now look, ITER is not going to solve our energy crisis overnight. It is a long, difficult, and very expensive investment. It's a message to our kids and their kids that we chose to be bold, that we chose to reach for a star. So the only real question left is, will this project be remembered as humanity's greatest hope or its most expensive gamble?